All right, thank you for watching this project help video for lesson 4. I will help you answer each question in the project by providing step-by-step instructions using example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in your project. All right, so let's take a look at question 1. The beaker on the right measures to the nearest 10 milliliters. John measures the liquid in the beaker and reports there are 50 milliliters. If there are 60 milliliters or more, then John needs to send the substance to the lab. Does John need to send the substance to the lab? And the idea is what this question is really testing you on is that you know that the error in a measurement is half as much as its precision. So if I tell you that this beaker measures to the nearest 10 milliliters, then we say it's precise to 10 milliliters. That means that the error involved in any measurement would be plus or minus 5 milliliters. So if I take the precision and divide it by 2, we get the level of error, the error possible in the measurement. All right, so in this case, the level of precision is to the nearest 10 milliliters. So if I take 10 milliliters and I cut it in half, then we can see that this measurement is really only precise to 5 plus or minus 5 milliliters. Any any reported measurement that I make, I know has that level of possible error. So take a look at the liquid here. The reason why that John said it was 50 is right because here's each tick mark that represents each 10, right? So here's 30, 40, there's 50. And he looked at these two lines and he said, it's closer to 50 than it is to 40. So it is going to be, I'm going to call it 50 milliliters, right? Just like we would do in your measuring. Say, however, though the liquid came up right to like here. Say it was just past that 50 line and the liquid was up there. Well, I'd still be asking myself, is this liquid, is it closer to 50 or is it closer to 60? And my eyeball here would tell me that it's closer to 50, so I would still report that it's 50. Now this is where the air comes in. So basically, if you cut each of these in half, I'm going to call this the halfway mark here, and I'm going to call this the halfway mark here. Notice that if the liquid was anywhere within these red lines that I drew, because it's more than halfway above this point and less than halfway above this point, that I would have to call it 50. I wouldn't be allowed scientifically to call it anything else. So I know that even if I don't have a picture, if somebody's saying that, hey, there's 50 milliliters in there and I know that it measures to the nearest 10, I know that it could be 50 plus or minus 5 milliliters. So there might be as much as 55 milliliters of liquid and as few as 45 in this case, milliliters of liquid. So then if the question is, hey, if there are 60 or more, then I need to go to the lab. And do we need to go to the lab if I said that we have 50? Right, so the only way that it could possibly be 60, right, since the air is only plus or minus, if it's 50 plus or minus 5, then it's as high as 55 or as low as 45, and there's not more than 60, so we don't need to go to the lab. Now, if John had said 60, then yeah, then we would have to do it. Or if I called it 55, which I'm not allowed to because this only measures to the nearest 10. And so all those questions that involve precision, that's what they need you to know, that if you take the level of precision and divide it by 2, you get the error that's in any given measurement. So it could be plus that or minus that from the actual value of it. So we're going to use that same idea here for question 2. Okay, so now James uses the top ruler and measures a piece of string and finds that it's 0.75 inches. And Daniel uses the bottom ruler to measure the same thing and also measures it to be 0.75 inches. Who has the more precise measurement? So notice they both said it was 0.75 inches. But this ruler up here, I've zoomed in on it in the inch here. You can see that it has tick marks here. They're in fact at every 16th of an inch. This is 1/16, 2/16, 3/16, 4/16, which is also a quarter. All right, so this is 4/16 of an inch. And if we reduce that fraction, right, that means a quarter of an inch. And we can see that that is a quarter of this entire inch. Same thing, this would be 8/16 or 1/2 of an inch. So we do see that this ruler here is measuring to the nearest, to a 1/16 of an inch. And it measures this piece of string, and here's this piece of string, and it measures it to be 0.75. All right, so this person down here, we measure the same piece of string using this ruler now. So on this ruler, it still looks like, it's like right there. And so this person calls it 0.75, but now you can see in this ruler here that we don't have tick marks at every 1/16 of an inch. We have them at every 1/8 of an inch. There's 1/8, there's 2/8 or a quarter, 3/8, 4/8 or a half of an inch, 5/8, 6/8 or 3/4 of an inch. All right, so the question is, who has the more precise measurement? So this guy, remember, just like the problem we had before, he's calling it 0.75. And if I take half of a 1/16, I get a 32nd. So the error in this measurement is plus or minus 1/32 of an inch. All right, so he's only off by this much. Whereas if I use the bottom ruler, which is only precise to the nearest 1/8 of an inch, all right, so the level of error in this measurement would be if I take half of an eighth, I get a 1/16. So in this case, this person's saying that the measure is 0.75 inches plus or minus a 1/16 of an inch. Well, since this one's plus or minus 1/32 of an inch, remember that's a smaller amount than this, then this top ruler, which measures to the 1/16 of an inch, is more precise than this bottom one. So in fact, James, who used the top ruler, has the more precise measurement. All right, so question 3. If a thief left the crime scene at 10:15 p.m., traveled at 65 miles per hour, and arrived at his hideout at 10:50 p.m., how far did the criminal travel? I think the quickest way to get at this one, this is the way I would do it, is by using the formula distance is equal to rate times time. All right, so it's saying if we know how fast the criminal is going and we know for how long he's doing that, we can calculate the distance that he went. And that's exactly what we want to do. There's only one step that we have to take before we can do that. And it's right here. We can go ahead and put in 65. And notice that 65 is in miles per hour. All right, so our time measurement here that we need to use needs to also be in hours. Sorry, that's in 65 there, but it's not right now. All right, that measurement is given in minutes. So I can't mix miles per hour and minutes, or else I'd have miles per minute. So I need to change the units. So I'm going to go ahead and leave 65 as 65 miles per hour. And I need to figure out how long this is. Okay, so we can do some subtraction. We can get that 50 minus 15 is 35 minutes. We'll go ahead and write out how I got that. So he's traveling for 35 minutes. So when you get to your question, you're going to have to figure out how many minutes the thief was traveling. And then we need to change that into hours. And changing this unit into hours, you can multiply it by the conversion ratio. Or since we know that there are 60 minutes in an hour, to change this into hour, all I really need to do is take that number of minutes and divide it by 60. All right, so when I go ahead and I do that on this problem, I get that 35 divided by 60 gives me this long decimal, in this case, 0.58, and then repeating threes, which I'm just going to leave like this. So that's a point, that's a decimal. All right, so now this is 35 minutes is the same as 0.583 repeating hours. Remember, so I need that in hours. All right, so now I'm going to multiply that by 0.583. That's close enough for me. We don't need to carry out a whole bunch of threes. All right, and then we just go ahead and multiply this. I'm going to multiply that by 65 because he was going 65 miles an hour. And I get that the thief traveled 37.916. That's a point there. And so I'm going to go ahead and round that to 38. And since it's 37.91, I'm going to go ahead and round it to the nearest mile, in my case, and call it 38 miles. All right, so the key here is knowing that you needed to change those minutes into hours and then multiply it by the speed to figure out the distance. All right, so question 4. It says, a semi-truck when loaded with iron rails weighs tens of thousands of pounds. In order to ensure that all the iron rails arrive at the destination, the truck is weighed. John thinks it's all right to weigh the truck with the scale on hand, which weighs to the nearest 10 pounds. Tommy thinks they should drive 50 miles away to the inspection station, which has a more precise scale that weighs to the nearest pound. Do they need to use the more precise tool or not? So think here, we have a big old semi-truck and it's carrying a whole bunch of iron rails. Each of those are thousands and thousands of pounds. All right, so we're just getting an estimate of how much this truck weighs, and then when it gets to its destination, we can weigh it again and verify that all the rails are there without having to count them. That's the idea. Now, if a truck weighs tens of thousands of pounds, like for example, 39,653 pounds, let's say that's what it was measured on the scale at the inspection station. And so when we measured it to the nearest tens of a pound, we'd have 39,650 pounds. Is this extra 3 pounds here, knowing that it being more precise to that pound, is that necessary in this case when the truck weighs so much? Right? Do you have to waste all that gas to drive 50 miles away so that you can find out that it's 39,653 pounds instead of 39,650 pounds? All right, and to that I say no, it's not worth it because we know that an iron rail weighs more than 3 pounds. So if one were to go missing, there'd be a much greater drop, probably a few thousand-pound drop, not a few pound drop. Right? So there really is no reason to go and use the more precise tool in this example.